And that was the break. We're back. With the heading transformation, it's in the same line of thinking. What if we end up a place where the normality assumption seems to be wrong? Now I'm exemplifying the most classical way such an assumption can be wrong. It's not the only way, but it's a very classic one. Here is some toy data. We make a normal plot. We don't even have the Wally. We don't have time to Wally this one now, and I cannot do the Wally now, so no Wally here. But look at it's not really a nice line. And if we Wally these, we will identify them. So, and also maybe we can look at the shape of this one. Maybe it looks a bit like this. This is not uncommon in biology, chemistry, economics. We've seen distributions like this already. It's called the log normal distribution, or it could potentially be the log normal distribution, because when we have phenomenon which are really positive phenomenon, stock exchange rates are like that, concentrations in the blood are positive. There's a lot of positive things in biology, chemistry, physics, economy, financial business, whatever, which often do not follow normals, but then they might follow log normals. Following log normals is a bit of a right skewed distribution where there's a lot of small values and then fewer. I mean, like I draw it, it could be the exponential also. The typical log normal, would be like this or something. It could also be the exponential, of course, but now we talk about the classic log normal. The thing is, the first transformation people are having in their minds, maybe even one of those a bit too much, but nevertheless, here it is. This is how it is. Also at Novo Nordisk and other places, well, if I have a problem with my normal, I log transform. Then it's probably better. And sometimes it is better for good reasons. In this case, and that is the low practical operational way to deal with something that doesn't follow a normal, then maybe we are lucky that when I log transform, and it's very low practical, I log transform, I make a new variable, which is the log transformed version of the original one. So I create a new set of observations on the log scale, and then maybe, just maybe, those observations would follow a normal. And I mean, the theory is that if something is truly log normal, then the log of that something would be normal, right? So working with normal distributions for the log transformed data is the same as assuming that the original data had a log normal distribution. The log normal is a bit complicated in itself. So it's nice to be able to work with a log normal by log transforming and forgetting about it and then do all the normal shit, all the normal business that we have learned and will learn for the rest of the course. And here we are. You can see the QQ plot for the log normal looks much nicer. I mean, I'm not telling you that every time in the rest of your life, if something is not normal, you can just log transform and everything is fine. But it's number one on the list of something to think about. So, I didn't bring slides here, but because it's actually related to some of the projects also. It's pretty nice with the log normal. The best thing with the log normal would be if you can just, to repeat myself, log transform and forget about it. And then do the statistics on the log transformed data and do all conclusions of means and whatever variances, just sticking to the log scale. And I mean, some scales are log scales. The Richter scale of earthquakes, for instance, that's a log scale. We're all used to that. We talk about that as if we all know it, and that's a log scale. So there are scales on there are log scales around that we are happy to work with. But I also tell you, if you work as a statistical consultant and a chemistry guy or biology lady or whatever comes to you and had some original data, and you say, as a consultant, we should log transform. Yeah, she says, yeah, you can log transform all you want, but when you give me the results, I don't want to see the log transform on my results. And they say, but you should, because it's not. I don't care. I don't want to see the log. I want the results on the original scale. All you talk about normality, I don't care. I want the results on the original scale. Well, fine. We go back to the original scale. And that's the nice thing about the log, is that you can take CIs. There is something in the notes about it. You can back transform by the exp to the CI. Not exact here. But if you compute a confidence interval on log transformed data, you can back transform it by taking exp to this and exp to that. And you can also back transform the estimate of the mean. And then we could leave it there and just say this is the back transformed means and the confidence interval for the back transformed means. If the log normal is the good model for things, then there is this nice point that you need a bit of probability to actually acknowledge completely that back transforming log transformed data to original scale, back transforming results is nice, but it actually makes the conclusions to be about the median of the original data and not the mean. And maybe that's what you want. And even doing log normal data basically is also saying maybe you should think about the median, not the mean. At least, I mean, if the data really follows a log normal, there's no guarantee it always becomes really, really nice, because maybe the data is not really log normal, but so maybe it doesn't really match up very nicely. But in theory, if data follows log normal distribution, it's nice to back transform means and confidence interval for means on log scale, and that gives you interpretations for median results for median on the original scale, which makes very good sense. We are happy about that. So that's fine. It's all fine. That's transforming with the log. Most common transformation used in the world. There are other transformations, square root, square, you name it. There are whole families of all sorts of transformations that can help you make data more normal, more nicely. This is a basic stats class. You are not taught the whole business in this class. You are introduced to this fantastic world of learning from data that will haunt you for the rest of your life. I'm sorry. The data will be there in your bed, at your office, when you do this, when you do that. I'm sorry. The data will be there. So, think about it. We are going to make a winner, but with one more question, I hope. Two more questions, actually. I missed out one. Here you are. Thank you, guys. Final question of today. Pineapple still in the lead. Tura is making a comeback. By the way, you Danish guys, Wally is like Holger, right? If you didn't get that point. That's wrong. You agree with me in being completely wrong. I hope the winner did not make the blue answer. I'm sorry about this. When we find Wally, it's because it's not normal. So I was too fast again there. I really need to be sharper on my answer. Do we agree now that it's wrong? Because last time I thought something was wrong, it was not wrong, so I was wrong on being wrong, and that makes us all confusing, I think. So the blue one is wrong. There is evidence against the normal. The data is, that's actually the only one I would put in here as a correct, because I wouldn't even be able to say that it's log normal. It's just one option there. So I apologize for this mistake. Do we agree now that I'm saying the correct thing now? Right? Now I'm correct. I'm not, because at the end of this, my brain is at 0 level. I could say anything now, and I wouldn't know whether it's right or wrong. Do we agree? Good. Thank you. Let's see who was the winner anyway. Pineapple did the winning. Actually, you guys were on the top before also, so that's fair. Would Pineapple like to show his or her identity? Good job, Pineapple. What about these guys with those names? Would they like to expose themselves? Number 3. I don't know what to tell you, but anyway, God damn it, we only have the fun we have, but nevertheless, find better names. I don't know what to do. So enjoy it out there.